Hello guys, it's JohnnyTime and welcome to another smart contract hacking tutorial. Today we will solve the 9th Damn Vulnerable DeFi version 4 challenge with Foundry, which is the Puppet version 2 challenge. This challenge is going to involve some Oracle manipulation attacks with oracles that are based on AMMs, decentralized exchanges, and it's going to be super interesting. So without further ado, let's get started. So this challenge is continuation of Puppet version 1, and in version 2 the developers of the previous pool seem to have learned the lesson and released a new version. Now they're using a Uniswap V2 exchange. In the previous version it was V1 as a price oracle along with the recommended utility libraries. Shouldn't that be enough? You start with 20 ETH and 10,000 DVD tokens in balance. The pool has 1 million DVD tokens in balance at risk. Save all funds from the pool, depositing them into a designated recovery account. So this challenge comes with Uniswap V2 library.sol file and Puppet V2 pool. This is the pool that we need to hack and drain the 1 million DVD tokens from the pool as mentioned in the instructions. So at a first glance, the pool looks pretty similar to the previous exercise, previous challenge, and difference here that we have also the Uniswap factory contract that we sent in the constructor, and the borrow function works the same essentially. Just the difference is in the way we calculate the deposited ETH required in order to borrow DVD tokens. And in the previous challenge the factor was 2, now it's 3, which means that the collateral ratio is only 33%. So for every $1 of ETH you deposit, you can borrow only 0.33 cents of DVD tokens. And instead of writing 1E18 like the previous challenge, they wrote 1 Ether, which is essentially the same. So every time you see 1 Ether, 10 in the power of 18 or 1E18, it's all the same thing. And now the way we fetch the Oracle price, the price of DVT compared to wrapped ETH, unlike the previous challenge where we relied on the pair or the exchange contract balances of ETH and DVD tokens, this time we use the Uniswap V2 library.getReserve function where we pass the factory contract, the token A and token B, and we're trying to get the reserves of wrapped ETH and the token. Now the difference between the balance and the reserves is that the reserves are stored in the state of the DEX smart contract, and it's not literally the balances that he possessed, whether it's ETH or the token. So these reserves are being updated only at the end of the operation. So if someone is adding or removing liquidity from the exchange or performing a swap, then during the swap and during the operation, the reserves are going to be the previous reserves, and only after the operation finished and succeeded, then we update the state, the storage of the contract, which are the new reserves. And this essentially means that if we would like to execute a flash swap using this particular pair to manipulate the liquidity and the reserves and the oracle that is based on this pair, it would be more complicated, but this is not the subject of this challenge. If you want to dive into flash swaps and flash loan attacks and all these kind of things more in details, check out the Smart Contract Hacking course where we cover this subject as well. I know that at this point, you might think you lack some technical knowledge to understand all of this with ease. That's exactly why I created the Smart Contract Hacking course. Instead of piecing together scattered resources, you will follow a structured learning path together with hands-on exercises that simulate real-life attacks. When you get stuck, our Discord community with security researchers and fellow students is there to help. And once you've mastered everything, you will earn an official certification to validate your skills. Transform from watching tutorials to actually understanding smart contract security. Visit our website to start your journey today. Then we use the Uniswap V2 library, the function quote, by essentially passing the amount that we want to get to convert from one token to another, the reserves of token A and token B, and then we get the quote, or in other words, the price of the token in the form of the other token. As we can see here, get reserves in the library essentially just returns the reserves. It sorts the token by the addresses, get the reserve from the pair storage, and just returns it. And the quote, what it does is essentially just creates this formula of amount A multiplied by reserve B divided by reserve A, which just converts one token to the other based on the given amount, reserve A and reserve B. So as I mentioned, we cannot manipulate these reserves using a flash swap because they are being updated only at the end of the operation. So we need to actually perform a swap with our own liquidity. And lucky us, we got some liquidity. So we got 20 ETH and 10K DVT tokens. And if the liquidity is not deep enough in this pool, we can essentially dump the DVT tokens and sell it to the pool, and decreasing its price, and then the Oracle price that is reported from this library based on these reserves is going to be significantly lower. And if the Oracle price is lower of DVT, it means that we can deposit a small amount of wrapped ETH because the deposit required of our ETH is going to be smaller based on the price of the DEX. And then we can borrow and drain all the DVT of the pool. So this is our goal here, similar to the previous challenge: perform a swap, dump the token price, then use our ETH collateral, the minimum required to borrow all the DVT tokens. And when we jump to the test file and we look at the state, we see that the liquidity is very, very thin in the Uniswap pool because we have only 100 DVT tokens and only 10 ETH, which means that 1 ETH worth 10 DVT tokens. But we want actually to dump it even further. So we're going to sell all our DVT to this pool, and we're going to increase the DVT reserves and take the ETH from the pool, take around 9 point something ETH from the pool. So we are draining the ETH, adding DVT to the pool. What we do, we essentially decrease the price of DVT tokens. So then as we come to the Puppet V2 pool, we are able to deposit a small amount of wrapped ETH to take all the borrow all the DVT tokens. So you can imagine that this player initial balance is being added to this balance when we do the swap. So it's going to be 10,100, and also we're going to get the ETH. So it's going to be like maybe 0 point something ETH left in the pool. And when the ratio is so big between the amount of DVT in the pool and the ETH in the pool, then DVT decreases in price in front of ETH, because this is how Uniswap calculates the price based on the reserves. So we are essentially playing with our cards, with our numbers. We are dumping the DVT, adding it to the pool, taking the ETH. Then we're going to have approximately 30 ETH. And then we use these 30 ETH to deposit into the Puppet pool to take all these 1 million tokens, which is relying on the reserves of the Uniswap reserves that we just manipulated. And this is our solution. Pretty simple, pretty straightforward. We don't even need a smart contract for that. We can do it directly in the test. The first step is to dump the DVT to the ETH. So we approve the router to spend all our DVT tokens, and then we prepare the path array, essentially which tokens we want to swap. So we want to swap from token to wrapped ETH. That's why token is at 0 and ETH at 1. We call the swap exec tokens for ETH function in the Uniswap router. And we want to swap all our DVT tokens, all the 10K tokens, and we expect to receive at least 9 Ether. We're not going to get all the 10 ETH because there is some kind of fee and slippage and so on. So we're going to get 9 plus. We send the path, we're going to receive the funds, the player account, and the block timestamp. I know it's not the safest way. Usually you shouldn't put block timestamp when you perform swaps, but this is not the context of this challenge. So I just don't care. I just want to complete the challenge. And now I left a note here. The DVT price significantly dropped since we swapped a lot of DVT for wrapped ETH and modified the reserve, modified. Now remember, after the swap, we're gonna get some ETH, native ETH, and we want to convert it to a token, to wrapped ETH. So we essentially call the wrapped ETH deposit function to convert our native balance, native ETH to wrapped ETH tokens. Then we check what is the DVT token at the same moment in the lending pool. It's going to be 1 million, but we just check it atomically anyway. So we have the exact number in case it changes, you know. Obviously it won't change because we're the only one solving the challenge. But when we write real POCs in real blockchains, the state might change. So we want to be atomically correct. And then we calculate how many ETH we need to deposit, how many wrapped ETH we need to deposit using this public calculate deposit of wrapped ETH required function in the Puppet pool function. It's a public function, so we can just read it. We approved the lending pool to spend this required ETH that we need to deposit in order to borrow all the DVT. And of course, we passed all the pool balance. We want to borrow all the DVT, all the 1 million tokens. And then we just call this borrow function. We can actually pass here the pool balance instead of this constant, and as well here. So we are essentially borrowing all the DVT tokens, all the pool balance, using our minimum amount of wrapped ETH after we manipulated the price over here, and eventually transferring all the tokens to the recovery account. So at the end, the pool should have 0 DVT tokens and the recovery account should have all the DVT balance. And by the way, if you get stuck or you're not sure, you can check out this GitHub repository with all the solutions. Feel free to leave a star and also check the other tutorials, the other playlist. I have a full playlist with all the solutions of all the Damn Vulnerable DeFi version 4 challenges. So definitely check it out. So definitely go ahead and check it out. The links will be in the description. Okay, now we're going to run the test Puppet V2 and we can see that the test passed, which means that we were able to break and complete the 9 Damn Vulnerable DeFi V4 challenge Puppet version 2. If you don't understand something, have any questions, ask them in the comment section below. If you enjoyed this video, make sure to click this like button, subscribe to the channel, turn on the notification button for more awesome content. And if you want to take seriously your smart contract hacking and auditing career, consider joining our community, enrolling to the smart contract hacking complete training, take it to the next level, make this commitment, get a certificate, connect with other people. Thank you so much, and I will see you in the next one.